Building a computer can seem intimidating, but trust me, it's not as complicated as it looks. Today, we're diving into a step-by-step guide to help you create a custom PC tailored to your needs, whether for high-end gaming or demanding workstation tasks like video editing and rendering. If you're a beginner, don't worry. I'll break everything down into simple steps, share tips on avoiding common pitfalls, and explain how to pick the best components for your budget. By the end of this video, you'll have all the knowledge you need to confidently build a computer. So grab a notebook, or better yet, save this video to refer back to later. Let's get started. Step 1. Define your purpose. The first question you need to ask yourself is, what is this computer for? Are you building it for gaming, rendering, and content creation, e.g. video editing, 3D modeling? Your purpose determines everything, from the processor to the graphics card, to even the type of cooling system you'll need. Step 2. Choosing a processor for gaming. Let's start with gaming. For gaming, the processor's single-core performance is crucial. Why? Because most modern games rely more on a processor's single-core power than its multi-core capabilities. Here's a quick method to find the best gaming processors. Open Google and search for CPU single-core benchmark list. Click on the first result, usually from cpubenchmark.net. You'll see a list of processors ranked by single-core performance. For example, let's say I pick the Intel Core i3-12100F because it's budget-friendly but offers great single-core performance. Write down the processor you choose based on your budget. If you're unsure, look at gaming benchmarks on YouTube for the processor paired with different graphics cards. This gives you a better idea of real-world performance. Step 3. Avoiding bottlenecks. Now, let's talk about the infamous bottleneck. This happens when one component, usually the processor, isn't powerful enough to keep up with another component, like the graphics card. For example, pairing the 2100F with a powerful GPU like the RTX 4090 will result in poor performance because the CPU can't handle the GPU's demands. To avoid this, after choosing your processor, search Google for processor name, graphics card name, bottleneck forum. Look for forum discussions or tools that calculate bottleneck percentages. If the bottleneck is below 10%, you're good to go. Step 4. Choosing a graphics card. The graphics card, GPU, is the heart of a gaming PC. Your choice depends on whether you value features like ray tracing, realistic lighting effects, or if you just want the best performance for your budget. Here's what to do. Search Google for GPU benchmark list and click on videocardbenchmark.net. Look at the performance rankings and prices. Choose a GPU that fits your budget and matches your processor. Example: NVIDIA RTX 3060. $330. Supports ray tracing but costs more. AMD RX 6600 XT, $290. Better raw performance for the price. For gamers who don't care about ray tracing, AMD GPUs are a great choice because they're more affordable. Step 5. Pre-built PCs versus custom builds. If assembling components yourself feels overwhelming, consider buying a pre-built PC. Many companies offer pre-built systems at discounted rates during sales. Just ensure the PC includes at least 16 GB of RAM. 8 GB is no longer sufficient for modern games. An SSD for faster loading times. For custom builds, note down the components you've selected so far, processor and GPU. We'll move on to other parts like RAM, storage, and the case next. Step 6. Choosing components for a workstation. For rendering and content creation, the focus shifts from single-core to multi-core performance. Programs like Blender, Adobe Premiere Pro, and After Effects utilize multiple cores for faster processing. Here's how to choose a processor. Search Google for Cinebench multi-core benchmark list. Visit a site like cpumonkey.com. Select a processor with strong multi-core performance within your budget. Example: the Intel Core i5-12600KF offers 10 cores and is perfect for rendering tasks. When it comes to GPUs for workstations, NVIDIA is the better choice because of its CUDA cores, which are optimized for rendering and editing tasks. Search Google for V-Ray GPU benchmark list to compare workstation GPU performance. I'll pick the RTX 3060 Ti for this example. Step 7. Other components. Now that you've chosen your processor and GPU, here's how to select the rest of the components. Motherboard. Make sure it's compatible with your CPU socket, e.g. LGA 1700 for Intel's 12th gen processors. RAM. For gaming, 16 GB is sufficient. For rendering, 32 GB is recommended. Storage. A 1 TB NVMe SSD is a good starting point for speed and capacity. Case. Ensure it has good airflow and enough space for your GPU. Pro tip: search forums for your build combination, e.g. 12600KF RTX 3060 Ti PC build forum, to see if others faced compatibility issues. Step 8. Avoiding common issues. Before wrapping up, let's discuss two common problems. Coil whine. A buzzing noise from the GPU under heavy load. While it doesn't affect performance, it can be annoying. Check reviews to see if your chosen GPU has this issue. Power supply PSU. Always buy a PSU from a reputable brand. Calculate your system's wattage using an online PSU calculator and add 20% headroom. Conclusion. Congratulations. You now know how to build a PC tailored to your needs, whether for gaming or rendering. Remember, the key is research. Take your time, compare benchmarks, and ask for advice on forums. If you found this video helpful, hit the like button and consider subscribing for more tech tips. Have questions? Drop them in the comments and I'll try to answer as many as possible. Thanks for watching, and I'll see you in the next vid.